Kristen, I love the title of your workshop. So it's called What Can We Learn from Thinking About Black Holes? Well, for me, any conversation about black holes is always inherently interesting. But what do you do in your workshop?
Well, we use that kind of as to start a discussion around what can we learn about the nature of science.
Okay, well, I know that we had not very long ago an image that was in the media of a black hole.
That's
In
right.
fact, some people called it a photo, didn't they? So for you, is this image of a black hole, is this a photo of a black hole or just an image of a black hole?
I think people might assume it's a photo or an image that's been snapped like a photo, but it's really not. It's kind of much more complicated how the image came to be. So the reason it's difficult is because it's so far away, and obviously a black hole doesn't let light kind of emit, so there is something there, but we can't see it. And what we're actually seeing is a shadow. What scientists are looking for is a shadow. The image itself was taken from 8 different radio telescopes across the world, because you would actually need a telescope as big as the Earth in order to find this black hole, to take an image. And what they did was bring together the data from these 8 different telescopes, and it took a computer 6 months to process the data, and then there were lots and lots of gaps in the data. So they had a computer algorithm to fill that in kind of based on how likely the next pixel would be something. And then after that, they sent it to 4 teams of people to kind of interpret and fine-tune the data. And
so what we actually have then, let me just go over what you've said, is, well, first of all, it's a very long way away. Secondly, it's black. So we're trying to photo, as it were, something that's black. So we're not actually going to see the black hole itself because that's black. We're going to see the shadow, as you called it, the evidence of the black hole.
Mm-hmm.
And then you're saying to me that actually we don't have one camera, we have 8 telescopes. Yeah. They take the data in over a number of days, I'm guessing?
Over 4 days.
4 days, all right. So this is a photo that takes 4 days to take, and then 6 months, you said? 6 months to develop, in inverted commas. And developing it is going through and interpreting this data. Right. And 4 teams did that. That's so like you say, this is really not like a selfie, is it? This is a very different kind of photo. Yeah. Yes, I can see how we are starting to think about the nature of science there, because we're starting to think about the way that science has got on top of some of those practical challenges that were there, that were preventing us from investigating a black hole. I can also see that it's really interesting that what was quite a simple word, photo, which we all thought we understood, we all rock up with the camera, that's a photo, that now this word is so much more complicated and we really have to think about what it means. So it's quite philosophical, isn't it?
It is.
Yeah, so I think to be a good scientist, you need to be a good philosopher.